is non-uniform. If it is non-uniform, that means velocity graph is coming again curve line. So there will be non-uniform velocity. In that non-uniform velocity case, you will not get a definite displacement. You will get the different displacement at different times. So the slopes will also be different. So acceleration values will also be different. So different accelerations value will get you. Suppose the slope at one place is this. Slope at other place is something, because this is the graph line. So different places of the slopes you will get. So slope values will definitely vary. So since slopes value will vary from velocity time axis, that's why the acceleration will also differ. Retardation may also differ. So acceleration differs means you are getting different values for acceleration. That way you need to find acceleration time graph also. In the acceleration time graph, here also you are getting the same thing. That is, acceleration will be there in the y-axis and time will be there in the x-axis. So acceleration also you can take what acceleration you want here, you have to note down. Whatever the acceleration you are getting here, you have to note down as per its requirement. Say 2, 4, 6, 8 in bigger places. So 2, 2, 2, 4, 2, 4. You may get acceleration, say at acceleration, if it is uniform acceleration, so slope will be 0. Slope will be 0 because the graph line is not touching the x-axis, so slope is 0. So slope is 0 means there is no acceleration. There is so this slope gives you no physical quantities. Slope means y-axis by x-axis, that is ordinate by abscissa. Ordinate by abscissa will be just nothing. No slope value is required here. No slope value is required here. What only required is area. What is the area of it? Area will be length into breadth the same way. That means when you calculate, I am just giving the hint to carry out, meter per second square is the one axis unit. The other axis unit is second. So second and second square when get cancelled, your last result will be meter per second. What meter per second unit is referring to? Meter per second unit refers to velocity. That means area of covered by acceleration time graph gives you the velocity of the body. If it is parallel to time axis, it is acceleration is uniform. If it is not parallel, if there is a slope, it is moving inclined, the area of the triangle will give you the velocity during up to this time. As the different places, different triangles may be formed at different timings. Different. That means different areas will be added to find out the different velocities at different times. That means this acceleration is uniform with the different velocities. So this can give you result for acceleration time graph as well, and that way it gives you the scale of that. So I think acceleration time graph will determine velocity time graph. Acceleration time graph may determine velocity time graph. Velocity time graph can move to the displacement time graph. They all can be reverted as well, because from acceleration time graph, when you are getting different velocities, you may draw velocity time graph. From different velocities you are getting the different displacement, so you may get the displacement time graph. So that way they are quite interrelated, that the graphs only can take you over to different physical quantities along with the slopes, along with the figures, along with their areas. So I want you exercising and practicing whatever the descriptions there in your textbook along with the diagrams, and read the diagram. I advise you one thing, class 9 boys, diagram is itself a language. Diagram is itself a language. Diagram speaks a lot. It rather speaks more than words. Diagram speaks more than words. So you must decode the language of graphs, language of the diagrams. That's why I advise you that according to the book you follow, but you exercise yourself, do read and do work out. There are so many things which I have just left out for you, just for this part of the exercise here, that you revert from acceleration time graph to velocity time, from velocity time back to the displacement time. Because we came from displacement to velocity time, from velocity time to acceleration time graph. You revert, you go in the opposite direction process. It can be by doing so. Mind all the time that will be not a uniform one, that will be a non-uniform acceleration. From there you will get velocity time graph. From non-uniform velocity time you will get the displacement time graph. So that is required. For a free falling body, there is an example given here for the same thing, doing from acceleration to velocity to displacement. So the last part of this goes like, so these figures and mathematical work, I think this is very necessary that you go for your own practice and work out and doing. For help, you take help, but don't leave any stone unturned. Just don't leave any stone unturned to understand it, and also to work out. If you work out more in number of times, it will be definitely very much clear to you. Also, I will set the numerical and theoretical questions from your textbook, which will be uploaded separately for this chapter. So this was the part B section, where we got the graphs in nutshell. Of course, the statement and what things are required there, it is there. I'm just leaving it out for velocity time. Since velocity is a vector quantity, it can be negative, it can be zero, it can be positive. Displacement is a vector quantity, so displacement can be negative, displacement can be zero, displacement can be positive. Similarly, acceleration is also a vector quantity. That's why acceleration can also be zero, acceleration can also be negative, which is called retardation or deacceleration, and the acceleration can be positive. In all these features you must go for. Your book has given lot of avenues, your textbook has given lot of avenues for your exercise. So I do end up here. I've just set questions. Of course you work out the questions, just tallying what I've discussed and what are there in your textbook. If some part is left in my speech, you just cover it up from the textbook. If some textbook is missing you something which I have spoken, just carry out from there. So my discussion in a short time and the textbook together will give you a right approach to the subject matter. So best of luck. Do prepare well and stay safe in your home.